So we've already learned how to expand our logarithms based on the properties, our product rule, our quotient rule, and our power rule. And now we're just going to do it in reverse. So the reverse process is called condensing. So we've got a few examples up here at the top left where we start with a string of logs. So in this first example, log base 3 of 4. Right here, log base 3 of 4 plus log base 3 of 5. Because I see this plus, I know that we're applying the product rule to condense into one log. So this becomes log base 3 of 4 times 5, the product. And of course, we can simplify 4 times 5 to 20. So there we condensed that log. In the second example, log base 3 of 16 minus log base 3 of 8. I know that's going to be a quotient rule. So log base 3 of 16 divided by 8 simplifies to log base 3 of 2. And then finally, we can also apply the power rule in reverse. So this coefficient, 4 times log base 3 of 2, we can go ahead and move that up as an exponent. So this becomes log base 3 of 2 raised to the 4th power. And then that simplifies to log base 3 of 16. So we're just applying our expansion rules just in reverse to condense. And when it says condense, at the end, you should have exactly 1 log. Okay, expanding, we're trying to split it up into as many logarithms as possible. When we condense, we need to condense it down into just 1 log. So if you got more than 1 log, you did it wrong. All right, so looking at 17 part A, let's see a few examples of this. So it says write the expression as a single logarithm whose coefficient is 1. So that just means apply the power rule. All right, so in A, we have log base 2 of x plus 3 log base 2 of y. So I see that we have a sum here, so I'm going to be using the product rule, right? But before I do that, I also see that I have this 3 out in front. So I need to pull that up into the exponent using the power rule. So I'm going to first rewrite this as log base 2 of x plus log base 2 of y cubed. So applying the power rule there. And now I'm able to apply the product rule. Log base 2 of x y cubed. And if you want, you don't actually need it because they're already multiplied together. But if you want, you can pop parentheses around that, and that's fine. Just be careful if you are going to put the parentheses. Just make sure you don't write it like this, because that's totally wrong, right? So just the y is cubed, not the x. So just be mindful of that. If you want to put parentheses, fine, but just put them in the right spot. All right, so for example B, again, we're going to apply the power rule first. We've got 9 log x plus 6 log y. So I'll pull those guys up using the power rule first. So this becomes log of x to the 9th plus log of y to the 6th. And now we can apply that product rule. Because it's plus, I know it's going to be the product rule. So condense that into 1 log of x to the 9th times y to the 6th. All right, in part C, log base 5 of 6 plus log base 5 of 4 minus log base 5 of 8. So here I can apply the product rule. So I can condense this to log base 5 of 6 times 4. And then we have our minus log base 5 of 8. And then in my next step, now I have that minus sign, I can go ahead and apply my quotient rule. So log base 5 of 6 times 4 divided by 8. So I have 1 log, product up top, and then divided by 8. And of course, I can simplify this whole thing. 6 times 4 is 24 divided by 8. So let's just call that log base 5 of 3. And there we go. All right, for part D, natural log of x plus 1 minus 2 times natural log of x minus 1. First move, I want to apply the power rule. I'm going to put that 2 up there as an exponent. And then because of this minus sign, I know I'm going to go forward and apply the quotient rule. So one single natural log of x plus 1 in the numerator over x minus 1 squared in the denominator. And notice, because this is all kind of one big quotient that we're taking the natural log of, I don't need parentheses around that x plus 1 because they're already contained, just being in that quotient notation. But in the denominator, because I'm squaring the x minus 1, I do need the parentheses around the x minus 1. So if you want to put big fat brackets around that whole quotient, whatever floats your boat, but you need the parentheses around that denominator. All right, and then for part E, there are a couple of ways to attack these, and you'll see that as these get a little more complicated and involved. There are different approaches, so you might start a different way and end up at the same spot that I do. But probably the simplest way to approach this is keep the 1/2 outside, and then inside the brackets, I see that we have that minus sign, so I know I'm going to be applying my quotient rule. So I'll just keep the brackets for now, even though I don't really need them after this step. So that'll give me log base 3 of x minus 1 over x. And then I have that 1/2 out in front. So now I can apply that as a power rule. Log base 3 of x minus 1 over x, the whole thing raised to the power 1/2. And it looks probably a lot cleaner if we go ahead and write this in radical notation, although if it says keep rational exponents, then we're done. But most likely, you'd be asked to convert this to radical notation. Raising to the power 1/2 is equivalent to putting a big fat square root. All right, and our last example, we've got power rule, power rule, power rule. So natural log of x to the 4th plus natural log y to the 8th minus natural log z cubed. Then we're going to apply our product rule and our quotient rule. And back in example C, I did this in kind of 2 steps. I'm going to do this all in 1 step now. So notice that these are all natural logs. And of course, all these examples, we've had the same base. So that's why we're able to condense this into 1 log. So I'm going to have 1 natural log of x to the 4th times y to the 8th. I know it's times because of that plus sign there. Pretend like I circled that. And then we have the minus sign down here. So our z cubed is going to go in the denominator. All right, so before we get too much farther in, we'll do this lovely example number 18. But I just want to show you guys something, just in case it's not clear yet. And I'll just use the common log, but this would be true of any log. So first, I'm going to just kind of make up a little example. Suppose I wanted to expand the common log of a times b divided by c times d. So I could start off by using the quotient rule, common log a times b minus common log c times d. And then we can split up the common log of a times b using the product rule, write it as log of a plus log of b. Now here's where it gets a little weird, and I want you guys to kind of pay attention here. So minus, so that minus sign is already there. And then if I want to break apart the log of c times d, I'm going to again use that product rule, right? So the log of c plus the log of d, common log of d. But we had that minus sign out in front, so if I distribute that, we end up with log of a plus log of b minus log of c and minus log of d. So that would be our expanded form there. You guys are all going to have the plus sign between log of a and log of b. You're all going to have the minus sign next. The tricky part is this minus log of d. So if we want kind of a quick way to approach this, notice that the log of anything from the numerator is positive, right? We've got positive log here, plus here. Anything from the denominator, we've got a negative sign, minus log of c minus log of d. So I just want you guys to notice that. The numerator, positive coefficient, denominator, negative coefficient, okay? And the same would be true if we're trying to condense. So if I were given that expression in the box and I was asked to condense it, I would know that the c and the d are going to end up in my denominator in the condensed version, okay? All right, so having said that, let's take a look at number 18. So this is a real doozy. First of all, I would rewrite this as x minus 5 to the power 1/3, because we like to have exponents rather than radical notation when we attack these guys. So I'm going to just rewrite that numerator as x minus 5 to the power 1/3. And in the denominator, I'll keep the x to the 6th, x minus 1 squared. Okay. So we don't have any power on the outside of our brackets, so we're going to go ahead and start by using our product and or quotient rule. So I'm going to break this into log of x minus 5 to the power 1/3 minus the log of x to the 6th, x minus 1 squared. And then notice we have this minus sign out here. I'll just carry this stuff down for now. 1/3. So we have this minus sign out front. I'm going to go ahead and put brackets around this. If I want to break apart log of x to the 6th times x minus 1 squared, because these are multiplied, I have a product. I'm going to use the product rule. Turn this into log of x to the 6th plus log of x minus 1 squared. But just like we did above, remember to distribute that minus sign. So now we have log of x minus 5 to the 1/3 minus log x to the 6th minus log of x minus 1 squared. And this is the guy that you're going to be in danger of dropping. So a lot of people will put a plus sign there and then it'll drive you nuts why it's being marked wrong. Okay, so from here we just have a little power rule left to fully expand this. 1/3 times log of x minus 5, and we need those parentheses around x minus 5 just as a reminder, minus 6 times the log of x, and then minus 2 times the log of x minus 1. And there we go.